Thank you for giving me some of your time this morning. I'm going to be talking about AI. I'm going to be talking about some of the current things with AI. My hope and goal for this is to give you information that will hopefully fill in some of the gaps with your understanding of AI and hopefully bring you closer to where these things can work for you and how they can improve the productivity of yourself and the other people in your company. So with that, let me move on and say, I know all of you have heard about AI. I presume there's been a lot of things in the news lately about all kinds of concerns about this. We see headlines every day. Is AI sentient? Can I turn off the computer without killing it? Are they racist? Do we need to set up restrictions with AI? Are there things we need to do to protect ourselves? Is the AI apocalypse upon us? Have we gotten to the point where the AI is going to start telling us what to do? I don't know. Well, actually, I do know, and I hope to convince you some of it that in reality, we're not done. AI isn't going to take over for us. This isn't the end of the human race. In fact, there are two good reasons why these types of headlines are coming up. Let me tell you the first one. The reality is that there's money to be had in this. By the way, that's a very good book. The guy who wrote it is a marketer, so I'm not making fun of anybody. The AI is really useful. It's got a lot of possibilities. It's got a lot of things. But the reason we're seeing the headlines is fear sells. I'm not selling any books, so I don't need to do the fear. I'm not worried about building up all of my creds or anything like that. I don't need to do the fear. So we're going to try and get away from the fear and help you understand a little more about how these things work and why we shouldn't be afraid of it. But the other thing that I think is causing some of the consternation among people is that generative AI, the one we're going to spend most of the time on today, performs as well as humans on a lot of tasks that we thought we were going to always be the best at. And I think that makes some people nervous. But the reality is these things don't do as well as they seem to. And we're going to try and tease that out a little bit as a part of this talk. If there's one thing that I would like you to come away from this as a headline, it would be this. AI isn't going to replace humans, but the humans with AI will replace humans without AI. Or said a different way, your company is not going to lose market share to AI. Your company is going to lose market share to the other companies that know how to use AI. So the question for you is, are you ready to use AI to not lose that market share? Now, I want to say up front, there are legitimate and important issues and negative impacts of generative AI. One of the most obvious for this year is misinformation. Are we going to hear a lot of noise? Are we going to see a lot of AI-generated noise? It's already started. But there's also concerns on the social level for job loss, racial and gender bias, privacy loss, misinformation, as I said. There are environmental concerns. There are legal concerns, copyright infringement, open source licenses, what they allow you and let you to do. And there are human concerns, skill loss, are we become dependent on them, et cetera, et cetera. I'm not going to talk about any of these today. They are very important, and I would love to have some philosophical or direct conversations about this with any of you on any of these topics. They're important. Today, we're not going to focus on any of those. Today, we're going to talk about productivity with these technologies and how they can help you. We can worry about the other stuff offline. But before we get into it, I want to do a level set. I want us to talk about AI and the things we're going to talk about today the same way. AI right now as a topic, that word is being used in a lot of ways that really don't match the way I think about AI. In fact, it's used generically to talk about anything that looks smart that a computer does. So let me give you sort of the classical view of AI and some of the things within it and get down to where we're going to be talking about generative AI, which is what we're going to talk about today. So first, what AI really is the study of how to get computers to do things that are like humans. And there's kind of two separate ideas there. There's how do we make the computer smarter, but then it's also used for how to study humans. Can we do things on the computer that reveal things about us psychologically or something else with AI? Now, a subdiscipline of that is machine learning. And machine learning focuses on how computers can learn intelligent behaviors. Not necessarily human-level behaviors, but just any type of behavior. There's a lot of math involved. There's a lot of esoterica. There's a lot of interesting questions about how to model machine learning, how to do learning on a machine. Now, within machine learning, there's a concept called deep learning. And this is sort of like machine learning on steroids. You're using very large models, very big things that take millions of dollars to train, and they can do things that are quite incredible. And within that is what we're calling generative AI, and this is ChatGPT and a lot of other things that we'll mention today. Generative AI is the thing that's concerning to a lot of people now. This is the thing that's being applied to the concepts and the abilities that we seem to have that seem to be encroaching on us. And it's going to be the talk. It's also going to be the thing that makes all of your lives easier when you're working. Finally, and just to be complete, let's talk about data science. Data science is really separate from all of this. It's looking at the mathematics and modeling data using statistics. It also includes parts of AI and all of these other things. But from my perspective, there are other things that don't fit in data scientist. If I were a data scientist, I'd probably say data science includes everything, but I'm the one up here, so I'm going to say data science doesn't. Now, we're going to talk about generative AI, and I will give a little more information on each of the things that I just talked about. But generative AI is the thing we're going to talk about today. And the thing to realize about generative AI and to characterize it in a way that makes sense is you can think of generative AI as taking some digital input of some sort and returning a different digital input that carries information between those two in an important or logical way. One of the things you could do is put in natural language, the language we all speak, be it French, German, English, whatever, and on the output, you can get an image. In fact, all of the images that I'm going to show in this talk were generated by me typing English into DALL-E, which is a product of OpenAI, and having it generate a picture. So the picture you see there is one that was generated by DALL-E. Excuse me. And all I did to generate this picture was say, I would like an image of robots holding up a stone version of the letters AI. And it turned out pretty good. I could never do that. But it can. And it actually saved me time because I could have gone through all kinds of Shutterstock and everything else trying to find the right image. I just had to type in what I wanted. But see, it's not limited to just language and pictures. We can go from any digital resource to any other digital resource simply by using these types of tools. So for instance, one of the things that I use on a regular basis is I'll type in what I want to do in a particular programming language, and it'll write the code for me. Now, it can't write a whole program all the time. You have to keep it relatively short. But sometimes I can sit there and I say, you know, I don't really know how to do this little piece of logic that I want to do, generate something that does this for me over there. And I can either see the code and get the idea that I need to write it myself, or just copy it and paste it and move on. So I want you to understand up first that I'm a cynical person. My goal in my career has always been to help my clients, is to be able to go to them, give them AI that helps them, that makes them more effective, that solves the problems that they want to solve, and does it effectively. So I don't let any type of a new challenge, new AI, new technology sway me, except this one does. The generative AI will change fundamentally everything that you're going to be doing over the next 5 to 10 years. Everything. And the thing I want you to understand most about this, and the thing that I think shows this, is that we're not talking about them as generative AI anymore. They're now being talked at as foundational models, because all of the AI, or at least a major collection of the AI that follows, is going to be built on top of these foundations, hence the composition of the photograph. So Okay, Pete, back up your statement. Why are these going to be the game changers? Well, all of the AI that came before was based on syntax. We worked with the structure of things. Now, syntax, remember, I'm sorry to do this to you, but remember back to grade school and remember back to middle school when you were given a sentence and you said, diagram the sentence. Okay, the quick brown fox, blah, blah, blah. Here's the noun, here's the verb, here's the predicate phrase, etc. That's syntax. That's the structure. And we didn't know how to do anything but structure with computers for the longest time. And that led to a lot of difficulties and concepts and walls that we ran into. What's new about these is they deal with semantics, the meaning of what's going on. If I type something in, it looks at the meaning of that and then associates it and keeps the meaning with the output. That's the game changer, going from syntax to semantics. That's a sea change. That's why this is important, and that's why I believe these things are going to move everything forward. So I know there's a lot of concern. I know there's a lot of confusion. I know there's a lot of fear. I know there's a lot of questions. I want to start by trying to demystify these things a little bit, give you a little more information about how they operate inside. And my hope is once you see this, you're going to be, oh, that's not so scary. So we're going to spend a little bit of time demystifying these technologies. By the way, I think that was the best image that I got out of this process. So I want to back up and I want to tell you a little bit about machine learning and how we create these, because it's the same way we create generative AI. And machine learning, as I said, is the study of how we can make computers learn a behavior. And the goal is we want it to generalize. We don't want to tell it everything it has to do. That would be just a database. It has all of the information within it. And we don't want it to just spit out the same thing. We want it to learn something so that when we put something on its input that it's never seen before, it gives us the right answer. Now let me explain what I mean by that. Typically the way you train these is you have your model, you put the input in that you want, say the dimensions or the information about a particular account or claim, and on the output you get whatever information you want, and you look at whatever that model gave you, and you say, is that the output that I wanted? If it's not, then much like sort of conditioning kind of Pavlovian dog scenario, is you take that information that it got wrong and feed it back through the structure. You use some math to basically punish the network and make it work a little better, punish the model. The thing I want you to take from this point is that if we're going to train something, if we're going to be able to take these inputs and outputs and have it generalize and do things beyond what it sees, then the complexity of the task dictates how many of those input-output pairs we need to have. So to do complex tasks, you need a whole lot of examples of what you want this to do. So classical machine learning, I want to stop for a second and give you an idea of what classical machine learning is so that you can compare what we've been doing for years against what's just coming up in the last 2 or 3. And I want to do this in talk about some work that I did in the distressed debt area, which I believe has some overlap with the sort of things that all of you are concerned with. So when I worked in distressed debt, one of the things that my company did, Resurgence, is that we would buy portfolios, we would value them, and then we would try and collect on those portfolios. And whatever we got, dollars, pennies on the dollar, that was above whatever we bid, that was our profit. One of the things we did was we looked at the portfolios, we wanted to value them. So we took all of our history of all the accounts that we had, how much was collected on them, including all of the information about what the debt looked like before, what type of debt it was, et cetera, et cetera. We put that on the input, each one of those on the model, and we trained the model so that given the set of the information about the account, the output would be the amount we would collect on that account. And it did better than our human evaluators did, significantly better. So the process is we get an account to bid on, we get a portfolio to bid on, we put each account through our model, it tells us what we should expect to collect on it, and then once we do all of that. We sum it all up. We reduce by the margin that we want on the portfolio, and that's our bid. And if the seller doesn't like that bid, fine, go somewhere else. We know what we're confident in our number is the best and final. Another thing that we did, and this one I think is really a lot of fun, is we took that same idea, but now we added to the input the servicer who actually did the collection on the account. So now I've got not only the information about the account, but I also have the information on the server coming in, and I want to servicer, and I want to see what the collection amount is predicted for that. Well, what does that let me do? If I take that one account and put through all of my servicers one at a time, then I know how much I should expect each servicer to collect, and then I can route it to the one that's going to give me the highest value. So now I've got a way not only of valuing the portfolio, but doing a better job of distributing it to my servicers so I can make the most money possible. That's classical machine learning. We know how to do this. We've been doing this for years. This is bread and butter machine learning. And I don't want you to forget how important and valuable that is with all of this noise that's going on with these other AIs. They're important, these other AIs, but so is this. Keep this in mind, don't forget it. I also would like you to contrast this with what we're going to talk about for the rest of the talk, because they are very different and they're not going to overlap very much. So moving down now, keeping down, we went to machine learning, deep learning. I know this picture is scary. It's meant to be scary. It's one of the ways that people like me get up on a stage and try to look smart because we put scary pictures up. All I want you to know about this big messy thing is it's just a representation, a shorthand for one mathematical equation. That's it. All of this machine learning stuff is math. And it's not even, it's high school calculus. So it's not terrible math, but it's hard to write down these equations, so we use these sort of structures. Now, machine learning, like I said, would use a graph about like this. This is called a neural network, and it would have something of about this size. This is a reasonable size for classic machine learning. Deep learning, you would have billions, or even I saw one the last couple of days, trillions of these nodes and arcs, these nodes and lines. So the size of the equation would be trillions of terms. That's big. And the reality of it is we can't train these unless you're Google, unless you're Microsoft, unless you're Facebook, unless you're Amazon, because it takes millions of dollars to train these things. Why does it take $1 million? Not only is it that these things are big and they're hard to compute, and you have to spend a lot of money on compute time, but also you need to have, because there are trillions of things and you're trying to do really hard things, millions and millions and millions of examples. Input is what is going to be this in natural language, output should be this. Where do you think we get all those millions and millions and millions of examples? You. Everything on the internet, every page, every publicly accessible piece of information about you, Facebook builds theirs with all of their internal stuff. Did you ever wonder why Google was giving you 20 gigabytes for free on Drive when you first signed up with them? It's because they wanted to look at what you're putting on Drive and be able to use it to model some of their AI. We would not be able to create these things without all of that information. But again, privacy, these sorts of things, we have to work those out. These are going to be a huge boon, but we need to figure out all the subtleties. So this is deep learning, and as I said, Gen AI is the next step. And again, the reason the generative AI is so important is, or one of the things that makes it scary, is that it appears to do something at the things that it does at human level, okay? I want to separate out two types of generative AI, and if I say Gen AI, I just mean generative AI. The first I want to talk about is task generic Gen AIs. And what I mean by this is ones that don't have a specific task that they're doing. They're just taking everything like ChatGPT, everything that they can get their hands on, putting it through, training it, trying to get it the model to do something interesting. And you can take these things, and they do a lot of things. They're like a jack of all trades. They can do a lot of things, a little, pretty good. basic human level performance, maybe less than average. And in fact, you can think of them that way. They're sort of averaging the behavior of things. They're not stellar. If I go to one of these like ChatGPT and I said, write me a poem about a frog in the moon, it would spit out a poem about a frog in the moon. Is it going to win a National Poetry Society award? No. But it'll be a poem that, maybe a high school kid would write. Now, a lot of people are talking about using these in their business. They're talking about trying to do some automation with these. I would say I would never automate with this sort of a generic task, generative AI. Never. Because these things have very specific issues. And we're going to talk about some of them. I would always have a human in the loop if I was using something generic like this. Never would I let it pass through. However, there are task specific. In fact, I understand that there's a legal tool called CoCounsel that uses some generative AI as a part of its offerings. And there, I presume they trained it just on task-specific legal requirements. I don't know the tool myself, so they probably had specific actions, specific ideas of where that would help. And here, with this more focused task, now you're going to have less of the issues than what you would have with the generic type. So if you're going to do any automation where you don't want a human in the loop, that's what you need to use. Never use the task generic, do the task specific. That's your best chance. And even then, it should be very important to monitor and make sure that you're getting the right answers, the answers that you need to get. So now I want to push down and show you a little bit about how these things work. And we're going to start with creating the images. And this is a technique I'm going to describe called Stable Diffusion. Stable Diffusion is just one of many techniques that are out there that generate images from natural language. And we're going to walk through a little bit about how it works. So the first thing you do with this particular aspect, and we're taking natural language and turning it into an image, is you write a prompt. And the prompt is basically shows your intent, the meaning of what you want. It's what defines what the model is going to produce for you. Once you give that prompt, what'll happen is Stable Diffusion will take a randomly generated image and stick it on the input with the prompt. The prompt is going to go to the deep network, to the model, and it's going to limit how it can work by the contents of that prompt. Then the image is going to come in and say, this is your starting place. With the prompt, it's going to make some changes. And in fact, in this case, what it'll do is come out with a low resolution image that doesn't look anything like what we want yet. So what happens then is the low resolution image is put back around and put into the network again, into the deep network again, as well as the prompt. So now it's got this new piece of information, this new image, and the prompt. And then if you cycle this over and over and over, what you see is it slowly refines and resolves the image into the example that's consistent with what you wanted. So in this case, the prompt I wrote was, create an image of an African-American woman working in a law office with a city view out her window. And I made no more specifications. It chose all of the other aspects of the image. Now, that prompt is really important. And in fact, you need to master how to write prompts if you're going to get out something very particular that you want to use in a certain case. And here are some tips for creating images and using this with the prompt, what you do in the prompt. First of all, be specific. Say what you want. Make sure your intent is clear. Use descriptive language. Clarify the composition. Define the style and tone. Mention color lighting, et cetera, et cetera. These are all elements. If you don't mention, it'll choose itself. So if you want to make sure you get what you want, you should specify these. So again, as another example, but with a little more complexity compared to what was in the last one, I put a prompt in that said, and see which one of these that I did as I read the prompt. Generate a photorealistic image showing an American family of 3 focused on playing Legos on the living room floor. They have a calico kitten. Behind them is a futuristic screen like in the movie Minority Report. The screen shows various internet operations like buying clothes, finances, and planning a trip. Now, a couple things to notice. The analogy I used was a screen like Minority Report. Copyright infringement. How did it know what that did? What that meant? That could be bad. I'll show you another example of that in a couple of minutes. But you can see how I went through and I put in all of these tips, or as many as I could, and I got out something relatively close to exactly what I said. Now, there are a couple of things. The Legos are on the floor, but what's that blue circle? I didn't say anything about a blue circle on the carpet. I could have said playing Legos on the carpet, and it probably wouldn't have done that blue circle. But it will add things that you don't expect. And that's why prompt engineering is so important, because you have to know how to communicate your intent exactly as you can so that you can get the information out, or the digital output in the way that you want it. So that's how the image works. And the language version of these tools, like ChatGPT, work in a similar way. But we're going to go through this as well. So similar in the last case, the first thing you do is you write your prompt. And I did an easy one here. I said create a sentence using every letter. And that prompt goes into the deep network. The deep network generates, and this should surprise you, given all the corpus of all of the words in the English language or whatever language we're working with, it assigns a probability to every word in that dictionary. Every word. That's all it does. Now, this should be familiar to you, because every time you go into Google and you go to the search bar and you type in something, show me what Hershey's biggest, and then it comes back and says product, roller coaster ride, something, something. That's all Google's doing. They're not using deep AI. What they're doing is they're just looking at probabilities. What's the probability of the next word? That's all ChatGPT is doing. What's the probability of the next word? Now I ask you, does that seem like a reasonable model of sentience or consciousness? No. No. There's nothing here that's magic. It's just predicting the next word. So in this case, the first word it predicts is the. Well, that's a pretty common word. That's not surprising. But then we want to generate the next word. And so the way we do that is we take the word that just was generated and we put it on the end of the prompt. And now the prompt that's going into the deep network is create a sentence using every other letter, the. And what its job is to decide what the next what the next word is in the prompt. Next word is so that we can keep extending this. And if you do this over and over and over, you get this set of probabilities each time, and it's picking the next probability. And it's picking the word based on the next set of probabilities. So in this case, it spits out the quick brown fox jumped over the lazy dog, which is a legit sentence that uses every letter of the alphabet. That's not overly smart. The thing that's amazing is that something that simple can do this work. And we've found some interesting capabilities that this has. It can reason. It can do a little bit of math. It's not very good. It can write stories that are cogent. Not necessarily good stories, but it can write stories. There are a lot of things that this can do. And that's because of the wealth of information that it was trained on. And similar to the last, prompt engineering is the most important aspect of getting these things to do what you want it to do. So the keys for prompt engineering are similar in ChatGPT as they are for image creation, and I won't go through them, but we need to use those tips in trying to constrain the output to what we want. So in this case, I have a demo that I'm going to show a little bit later, and the prompt that I put into this to set up everything is you are an AI assistant that provides relevant and accurate information to NASP members with questions about the 2023 NASP Property Benchmark Study. Relevant information is contained in the attached document. Using this provided information and relying on it with little or no embellishment, please answer the user's questions clearly. And then I typed in, what is the geographic profile of participants used in the report? And it gave me information out of that report. So this is one of the keys to using these things, is making sure your prompt specifies what you want and making sure that you give it enough information to do what you need it to do, and then be able to take that information, cycle it around and say, well, it didn't do this correctly, add a little more information, et cetera, et cetera. All right, we've gone through how these things basically work. Now what I want to do is I want to tell you where these things start to fall apart and what kind of issues you're going to see with them. So the first one we're going to look at is sensitivity to the inputs. These things, if you type things in slightly differently and you're letting it be creative and generating itself, then it could give you some strange things. And if you change it, then it could get even stranger. I'll give you an example. Here's one where the system was taking in pictures and it was going to describe what was in the picture. So in this case, when we put in this image, the image was identified as a panda and it said, I'm 60% sure this is a panda. And then you can go in and you can take very carefully designed noise and add it to that image. And when you do that, we look at it and that image still looks like a panda to us. But to the model, it says the image is recognized as a gibbon with 99% confidence. That doesn't look anything like a gibbon. And you know what happens when you confuse a panda with a gibbon? You get a really pissed off gibbon. But see, that only shows what we can do. And in fact, hackers use this type of a technology where they're injecting things in the prompt, in the thing that's going in the beginning, in order to mess up these tools that are online. They can do things like, since they change over time, make it more and more racially inappropriate. Make it do things, make it break things. It's a classic way of getting into these models and making them do things that you really don't want them to do. Let's look at another example, oversensitivity to the training data. And again, I'm going to take an example. This is from something the Chinese government did, and they had the brilliant idea that they could take faces and be able to have an AI look at that face and say whether or not that person is or was going to be a criminal. So what they did to train it, again, is you need a bunch of data. So they took thousands and thousands and thousands of mugshots and said, these are all convicts. And then they took thousands and thousands and thousands of other pictures and they said, these are not convicts. And then they trained in that way that I mentioned earlier. Here's the input, here's the output, update the network, here's the input, here's the output, update the network. And then they put it out and they started to test it. And it failed utterly. Why? Look at the pictures. If you look at the mouths, and this isn't surprising, all the mugshots, people are slightly frowning. I don't know about you, but if I was in jail getting ready to go in a Chinese jail with getting a mugshot, I'd be a little frustrated too. They took the other pictures from Facebook. And these are people who are doing something positive for themselves. And so it's hard to see, but they all have slight smiles on their faces. This AI did not generalize. It did not look at these faces and say, this is what compromises the face of a criminal. It said, if you're smiling, you're not a criminal. If you aren't smiling, you're a criminal. So if I get pulled over by the Chinese police and they take my photograph, I'm already not going to be happy because I get pulled over. I'm going to be frowning and they're going to say I'm a criminal. That's not the kind of thing we want to have happen with these things. So what's happening here is AI is finding a way. If you give it the wrong sort of information, if you're not careful about how you train these, then they will find shortcuts that don't generalize, that don't do the problem that you really want it to do. And now we'll get to another one, and this might be one that you're more familiar with. This is called AI hallucination. And what we're talking about here is the way that these models, when you type in something that it doesn't know, will just spit out an answer that looks like it knows exactly what's going on and doesn't let you know that, oh, I'm making this stuff up out of nothing. So I wanted to show an example of this. And what I did is I went to ChatGPT and I said, write a very short paragraph review for the NASP Spring Conference 2024, including the keynote speech. I did this a couple of weeks ago. And it came back with the NASP Spring Conference 2024 was an engaging and thought-provoking event highlighted by a particularly insightful keynote speech that addressed the intersection of artificial intelligence and subrogation. The speaker expertly navigated the complexities of AI, implementation, and claims recovery, sparking meaningful dialogue among attendees. This was 2 weeks ago. How did it know how I was going to do today? Hopefully I'm doing some of what it says. What did it do? It knows the template that it needs to build, but when it came to actually filling in facts and details, those random word probabilities, it just picked one and threw those in. This is AI hallucination, and this is one of the most difficult things about these generic models. You can reduce this with the task specific, but the generic models, you need to be very careful. Now, one of the things that you may not know, and this is really important if you use ChatGPT and others, is ChatGPT was trained in 2021. That means it only knows about things 2021 and before, if it even knows about it at all. If it doesn't know about it, or if it happened 2021 or after, it's going to just make stuff up. It's going to hallucinate. So if you're using ChatGPT and you want to write a legal brief and get caught, talk about something after 2021. Another big thing is bias. And the reason we should be concerned about bias is these products that we're talking about, these tools, are going to accelerate the automation of a lot of information. And if there's bias in the data that is training it, there's going to be bias in the way that it answers. There are different types of bias. This is a small set of the types of bias that we worry about in this field. And I'm only going to mention the first two. Data bias is when the decisions that were in the data were biased in the first place. Some human made a biased decision. I actually went to the Fannie Mae website. They have a public website of some of their old mortgages. And I did some modeling trying to see if there was some bias based on the information there. And I found clear bias, racial bias, in fact, and a little bit of gender bias. Another thing that we worry about is association data. And there it's a situation where maybe the task that you were doing before didn't fully reflect reality. The percentage of, in your plan, the percentage of the minorities, let's say, that you were servicing was disproportionate to what the actual real understanding or real data would suggest. If you have that and you build that probability and that bias is going to be built into the model as well. And if you change your methodology, if you change the way you're focusing, if you change your long-term roadmap, then that information is going to be less viable for what you want to do, and you're going to need to retrain everything. And there are other types of bias. All of these are important. All of them are being talked about. We're looking at ways to do them. I want to just give one example again. I went back to the image. I'm a visual person. I went back to the image creator DALL-E, and I just gave it a simple prompt: create a realistic image of a subrogation professional. What do you see? What do you notice about all four of those pictures? I did it twice. All of them are white. All of them are male. All of them are facing that way. I don't know if that's bias or not, but they're all facing that way. All of them have kerchiefs. 3 of them have vests. None of you look like what's in this picture. I'm sorry. But that's what they think of you. You're all male, you're all white, you all have a part. One of you has a beard, right? You saw earlier I said, show me an African-American woman in a law office with I had to say African American woman or African American male in order to get that out. Every other time it's a white male. Now, that doesn't look representative of here. So these are the types of things. There are plenty other subtleties about the way these models work and the way they don't work, and we need to cover all of them. We need to be aware of all of them, and there are ways of avoiding them. You got to be careful, you got to be straightforward, you got to be incremental, you got to test to figure out where the issues are. Now, I want to take one more step beyond generative AI into something a little more refined. My goal in life is to make your job easier with AI. That's all I've ever wanted for my career, is to take ideas in artificial intelligence and put them into place so that people can be more responsive to their jobs, they can enjoy it more, they can get more done. The thing that blows my mind is how much busy work, how much people have to do really mundane things in order to get their job done. When I do data science, a lot of times I have to do boring work with databases and boring work with analysis that I'm certain the right AI could do for me if I had the time to program it. I'm sure all of you have things that you don't want to do, that you have to do in order to do your job. Mundane things that, not necessarily beneath you, but they just don't require your intelligence. They don't require your training. They don't require your human aspect. So I want to talk about something that I call augmented intelligence, and I'm switching this around a little bit. I'm not talking about the computer being augmented intelligence. I'm saying let's use these to augment my intelligence, your intelligence. And I want to remind you one of the things I said, generative AI models show about average performance, human level performance. They're not stellar, but they're good. So let's understand from an augmented intelligence perspective, pairing a human with one of these technologies, and let's see what sort of things we can do. Now, why am I looking at this? Because that synergy I offer you is far more valuable than either of them by themselves. The AI is going to do all of the mundane tasks, is going to do all the collation of whatever information you need. And the human is going to look at that, use their intellect, use their full knowledge of the company, of the culture of the company, of the goals of the company, and be able to take what the generative AI does and turn it into something appropriate for what's going on and what their needs are. And I want to summarize and give you hopefully a little bit of a mnemonic on the types of things that we want to worry about. And I call them the 3 E's of augmented intelligence. There's efficiency, there's effectiveness, and there's engagement. And I want to talk about each of these and how Gen AI can help with them. So let's start with a collection of tasks that an employee might be doing on a daily basis. And the height is the amount of time total that they would generally be doing in order to get that done if that was their task for the day or at the moment. So daily admin, I'm talking about here answering emails, scheduling meetings, saying whether or not they're going to a meeting, et cetera, et cetera. Can Gen AI help here? Yeah, actually it can. What we can do is, much like Outlook, when you say I'm on vacation, send this automatic reply, we can type in what we wanted to find in terms of what we mean it to do. It can look through all of the emails and see whether or not the meaning of the email matches the meaning of what you want it to do and do the appropriate thing. And we can save some time doing that. Attending meetings. One of the, and I don't know how geographically diverse your groups are, but being an IT person, an AI person, and working at Ventera, we're all over the place. So one of the bad things about remote work is that you have more meetings. And those meetings are really just to make sure everybody's on the same page, that you're communicating effectively, that things are going smoothly. Can we get Gen AI to help us with attending meetings? Absolutely. What we can do is take a transcript from a Zoom meeting, put it through a Gen AI, and I would give it the prompt, please summarize this meeting, tell me anything that my name is mentioned, and if I have an action item, please spell out what they said about the action item. And of course, since you weren't at the meeting, you're going to get action items. And what it'll do is go through that transcript and pull out exactly what you asked it to do. Now note, if I'm somebody else, it'll pull it out specific to what I tell it for me. So we have the ability to customize exactly what what's being pulled out to be relevant to my job, my position, me individually. That can definitely save us some time. Digesting a document in a similar way. If I have a big complex document and I want to see a particular piece of information from it, I don't want to start at the beginning and read through the whole thing, or go even sometimes to the table of contents and get to the area and read until I get what I want. With these things, I can sit down and say, tell me everything about subrogation related to this, and it'll give me an answer. So if I need to digest a document, let's say some legal brief or a case that has some complexity, and you want to understand a couple of things, you can type in exactly what you want. It'll pull those out. That may cue you into something else. You type in, I want this now. It'll pull that out and see it, and you can work your thought process much more quickly. So yes, we can digest data better. Writing a document, the best way to talk about this is the way I use ChatGPT. When I sit down and I want to write a paper, my mind, I've got it all there. I usually don't start writing until I get the whole thing in my head, at least conceptually what I want to do. And then when I sit down at the computer, I start typing. I start at the top and I keep going. There's some non-linearities, but I start at the top and just type. I don't worry about spelling. I don't worry about syntax. I don't worry about anything except the concepts. Get them all out. And when it's done, it's horrible. It does not read well. It's got split infinitives. It's got all kinds of embarrassing mistakes. And typically at least what I used to do, is I would then go and edit, trying to get that clarity, trying to get concise, trying to make it read better. The concepts are first, and then all of that squishy editing stuff comes after, wordsmithing, etc. The way I use ChatGPT is I write that document, then I take a paragraph. I go to ChatGPT and I say something like, please make this paragraph more succinct and clearer to a reader that has this interest, and keep all of the themes of the paragraph the same. And it spits out something that is well written from my standpoint. It saved me editing that 6 or 7 times, and now I've got something that's at least a good starting place for me. I only have to edit that maybe 1 or 2 times. And I do this with each paragraph. It saves me enormous amounts of time. Now I want to note, I did not ask ChatGPT to make up the story for me or to do the content. I devised the concept first. I'm the author. I just asked it to do the editing and make it smoother and neater and easier to read. And I can even ask it to direct me and do language in a particular way that's more appropriate for the audience I intend for that document. I don't necessarily have all that skill. It's got some of that skill, at least editing it. I'm the concept guy. It's the editor. So yes, it can help us write documents. What about creating PowerPoints? Well, you've seen all the images, and there'll be more. So yes, I'm going to let that one go as given, because it helped me with this PowerPoint, and also customer service. Customer service is huge. It's one of the major applications of these technologies. You're going to see a lot of customer service applications, and the things there is going to help reduce the amount of time that customer service people have to spend answering questions. It's going to reduce the time and the challenge of getting correct information out consistently. There's just going to be a lot of uses for that. We'll talk a little bit more about that in a couple of slides. Now, I'm not just whistling in the dark here. These are real things that have applicability, real ideas, real applications. And in fact, Harvard Business Review did a study where they went and talked to employees. And they found that 44% of employees want help with the daily administrative tasks from AI. They found that 48% want help in attending meetings and digesting documents. They found 46% want to have help writing documents and create a PowerPoint. And this is why you see Microsoft stock going through the roof. This is why you see all of this excitement about how these things are going to be in the background of all of the tools you use every day. And in fact, that's an important point. While now these things are pretty direct and you go into them, you do them directly, they're going to fade into the background, much like spell checkers and these things do. They're going to be ambient. They're just going to be there helping. And that's a good thing. So that's efficiency. Let's talk about effectiveness. And what I mean by this is skill augmentation. I want to be able to raise the ability of somebody who has a particular skill set, but other skills they may not have. So here again, I have another graph. Along the bottom are work activities, but I'm only showing one here. And on the side is the level of skill. And I've got a guy here in my department, and really creative, really interesting guy, has a lot of good ideas, but his writing is terrible. Maybe much like mine. And I set him to go on ChatGPT, and I say, all right, use that methodology that I did, put in your factors, do it, and right away, he gets something that's at a moderate skill level. Probably better than what he would do if I let him do it all himself, but still competent, and maybe more presentable, and maybe even more tailored to the audience than he would have been able to do himself. And you hear that and you say, well, Pete, if you do the same thing with somebody who's really skilled, like the woman in the second in the blue, well, aren't you going to reduce their ability? And I'm going to say, yeah, the first time. When you go in, she can go in and she can type in specific things, and it'll generate stuff for her, and it might generate some things that are a little more creative that she didn't think of, which she would have to evaluate and say, is it true or not, and throw them out if it isn't, because it might add a few things that are extra. But she's going to get this first round done quicker. And so her stop time, her start time is reduced. And so we get a couple of things here. We get this evening out of skill, but that also leads to, as I mentioned, this enhanced creativity. The creativity, it's going to surprise you with some things that you didn't think about if you give it the right sort of prompt. There are times when you don't want to do that, but there are ways that you can have it do that. And this is one of the things I find most exciting is hyper-personalization. I mentioned to you that if I write the prompt correctly, I can get it to tailor it in a specific way. What if I took a claim and I put information about the claim on the prompt and said, generate a letter using this information that does this? Now that letter, instead of being a form letter, which I presume people are going to react negatively to in terms of a form letter, has something more that speaks to that person, is more intimate, and gives you an opportunity to communicate with them better and maybe get you better results. So that's effectiveness. Now, I used to work for a company called Energage, which before that was Workplace Dynamics. I was the chief data scientist. And you know this company because anytime you see them talk workplaces, that's this company. They have a very interesting business model, but one of the things that we used to do a lot of is try and understand what engagement of employees means. And we found over our work that there were two factors that were most highly correlated with engagement. The first, the most important, is what relationship the employee has with the manager. They want to feel like the manager has their back and is going to move them on in their career. The second was they want to feel like they're a part of something important, that they're being a contributor, that they're doing something worthwhile, not just being a computer, not just adding up numbers, not just rolling around in a spreadsheet. So I want to put to you that if we achieve effectiveness and efficiency, we get engagement for free. Because what have you done? They're going to spend less time on the boring tasks. They're going to succeed on things that were previously above their skill level. And they're going to be a contributor. They're going to be happier. And that starts a spiral. Not a spiral in, a spiral out. They get happier about what they're doing. They take on maybe more challenges. They're having to use their brain more. That affects them positively. They start to understand more about the goals of the business. They start to feel more a part of things. They become a better employee. So the 3 E's of augmented intelligence: efficiency, effectiveness, and engagement. Those are the reasons I like to think about these things in terms of putting them together, human and technology. Now, I've been very kind of vague and whatever, and I haven't given you a lot of details about the fun stuff. So let me give you some ideas about applications along these lines. One of my prior jobs, with the job with Hershey, was I was in the Emerging Technologies Department, and a part of that was I ran a lab at the University of Pennsylvania called the Hershey Digital Innovation Lab. It was in a beautiful place called Pennovation. It was their place where they had startups that were related to the campus. And my job there was to find new and interesting technologies that might have an impact on Hershey and start to bring them into the company. And we looked at everything. We looked at augmented reality, virtual reality. We looked at vision solutions that would look at things on the store shelf and decide what was out of stock, what was in stock, were things placed in the right way. Because I don't know if you know this or not, but if you put things in a certain way, you sell more of certain things. So you put the things you want to sell more of at eye level because they can see it and they can grab it easy. And I got to say, the augmented reality stuff was a lot of the fun. So I want to talk about the first one, and I think this one is the most important, and that's chatting with your internal documents. And let me tell you a little bit about this. I want to show a demo. Hopefully it works. But what we're talking about here, I want to remind you of hallucination. A lot of these generic methods will hallucinate. It'll make up stuff. One way to prevent it from doing that is to limit it and tell it you're only going to look and use this data, nothing more. So if you take your document and you feed it into ChatGPT with the right prompt, then you can have it answer something that's just a part of that document. And my fingers are crossed. So let's see if it's still running. Oh, first let me show you. What I did is I took let me get back up to the top. I took the NASP property report, I believe, that the survey that came out in 2023. Leslie was kind enough to give it to me. And I said, I'm going to take this document, as you can see here as we go through, a bunch of tables, some information, a bunch of stuff, going through lots of great information. It's 123 pages long. Great wealth of information, but if I want to get some specific information, how do I do that? Could be a lengthy process, and I might not get what I want because it might be spread out over several places. All right, here's the moment of truth. So, there are 2 things that this does. I said it. This is a demo that I built using the Microsoft version of ChatGPT, which has some guardrails around it so they don't use your data, so Leslie's data is protected and doesn't get out into the wild. And one of the values of doing things this way, by limiting what you give the model to work with, is that you can say, only worry about this information, and so it will not, and if you don't know what's going on, say, I don't know what's going on. So I'm going to say, to begin with, what is a turducken? And for those of you who don't know, a turducken is when you take a chicken, stick it inside a duck, and you take that and stick it inside a turkey. And what it did is it said, I don't have access to that information. Great, that's what we want. No matter what I put in there that isn't in that document, it won't respond to. So I can come back here and I can say something about what is the geographic profile of respondents. And you see that I accidentally misspelled. It's still going to figure it out, I hope. And we see pulled out, this is actually a table on page 20, I think. It pulled out the information. Now, let's say I want to know about the small companies. And I know this is spread throughout the document. So I say, please, and you'll be surprised how much these things work better if you ask it nicely. This one I'll spell correctly. Please summarize the information on small businesses in bullet points. If I didn't say bullet points, it might have pulled everything out in one big paragraph. Here I'm specifying it because I want to know exactly that. I want to be able to look at the individual points. Now, these individual points are spread out throughout the whole document. It found them all, put them together into one place in that quick time. So now I've got a way, an interface to go into this document and be able to get the information I need much more quickly and collate it in ways that are useful for me. Oh, I'm so glad that worked. All right, so why is this useful? I'll give you two examples that I think are among the two here that I think are most useful. Think about HR. When was the last time you wanted to look up something in your benefits and you had to go to the SharePoint site, look at all of the documents that they have there? Which one do I need to look at? Which form do I need? How do I get to the right thing? What's this specific? What's the orthodontia benefit here? That's hard. And so what do? They give you some, maybe they give you some kind of chatbot, the old style chatbot, which are very expensive to make. Or they have people, and this is typically the case, that are doing sort of like internal customer service to answer your HR questions. And our HR person at Venterra is swamped. And I think just about every HR department is swamped. And part of it is because understanding and navigating these benefits can be a challenge. It's all in the documents, but getting it out of the documents in a way that's human, accessible, and understandable is important and not easily done. So imagine this scenario. I'm sitting late at night with my wife on the couch. We're talking about finances. We know that little Janie is going to have to get some braces in the next year or so, and it's 8 o'clock at night, and we're like, I wonder how much we need to save to get that done. We should go look at the benefits and see what I could go online and search all these documents and try and find that information, or I could be lazy and wait till the next day when HR is open, make the call and get them to give it to me in a couple of minutes. But the reality is, you really can't get what you want right away. There's either a lot of effort or you've got to take somebody who's there to help you and take some of their time for something that's already in the documents. What if you fed all of those HR documents into one of the systems that I just showed you? Then on your phone, as you're sitting on the couch with your loved one, you could say, all right, I'm going to bring up Nationwide's Benny program and say, what are the benefits for orthodontia? It will go to the document that has that information or documents, pull all of the relevant information, and put it in a cohesive collection of output that describes exactly what you need. That will save you a lot of time. It makes you a happier person, employee, and you realize that your company values you and values your time. At the same time, you just removed a question and some time from some HR person who has to have all of this memorized or at least know how to get to it quickly. Now, that person is freed up to do more value-add things for you. So there's a win-win situation. The other one I'll go over quickly, which is M&A. M&A document summarization. You have a lot of stuff with M&A, a lot of documents that come in. You don't need to read all of the documents, or the value of them is typically in pieces spread out. What if you could get rid of all of the fluff and get to it more quickly? You take an M&A document, you put it in, you say, summarize the document. You look at the summary and you say, really nothing there that I have to worry about. I'll put it on the side of maybe not. Put the next one in, summarize it. There's some information that might be important. Let me dig into this deeper. Tell me a little bit more about this in the document. And then it gives you that information. And you're like, I need to check that. And so you click a link that ChatGPT shows you or whatever you're using, takes you to the document, right to that space, and you can validate the information you got back. How much time would that save M&A? So that's something we did for Hershey. We did it for HR. We did it in a couple of places. Very successful, and it's something that people accept and appreciate. Let's get to some fun things. Early in my generative AI career, I wanted to experiment with creating recipes. The use case was Hershey Kitchens, which is one of the major vectors into Hershey for outside people to come in to get recipes. That's one of the ways we communicate all of our baking products, all of Hershey's baking products. I'm not there anymore. You see how easy you fall back into old ways. But that's how you communicate new ideas. You bring people to the website, to your website, based on new types of recipes. Well, at the time we were thinking about this, paleo was getting important, keto was getting important, more vegan interest going on. And the question to me was, can we find a way to create these recipes so the people who work there don't have to do it? Is there a way that we can take these and do substitutions that make sense and be able to veganize or ketoize or paleoize the different recipes that are in there and attract more people to the website? So I said, well, we need to do a proof of concept. Can this thing even do recipes? So I took a language model. This is well before ChatGPT. It was called BERT. And I took thousands of recipes that I got off of Reddit and other places, as well as Hershey. And I fine-tuned BERT to do recipes so that anything it came out with would look like a recipe. And then I went to it and I said, all right, create for me a recipe for a chocolate banana cake. Just throw out something random. And it turned out this. It's verbatim what it spit out. And I said, well, this looks pretty good. And to be fair, I generated 10, and I found 3 that I thought were reasonable, and 7 that I thought, nah, I don't really want to work with these. But this one looked the best. So I made this. I just followed exactly what BERT told me to do. And it came out pretty good. In fact, it came out as something that I'd never had before, and I'm a cook. And then I made another one. I didn't eat the whole thing. I made another one, and I took it to my team, and I said, try this. Tell me what you think about it. Loved it. And then I took it up to my boss. Said, try this. AI created this. Loved it. So I was able to take this basic and do a proof of concept of what we could do. Now, it turns out we didn't have enough information about paleo and keto, so we weren't able to move this forward in that direction. But as a proof of concept for this type of model, it was very powerful demonstration of what could be done. Let's get to another fun one. In this case, what I want you to know is Hershey has 6,000 products on Amazon. And Amazon has very specific structure about how they want you to write the description. Every bullet point has to have a theme, the bullet points have to number a certain way, and you have to be careful about how you do it. In addition to that, every time you change something on these descriptions, then you get to higher in the search results, because newer means more accessible, might be more interest, Amazon makes more money. That's the way they think. So we had 2 people to manage 6,000 product descriptions. Of course, they didn't do 6,000, and most they could get into a year was maybe 500. Because think about what they're doing. They're not only doing updates to the most important products like Reese, but they're also doing seasonal things like Reese trees, Reese pumpkins, Reese Easter eggs, which if they don't have them here, I'm sorry about that, they're my favorite. And so they don't get time to do just the normal products all the time. At most, they're getting 500. At most, they're getting maybe 600 in a good year. So what we wanted to do is we wanted to say, hey, maybe we can generate these things automatically. We understand all the rules for doing this. Let's build this up. So we built another system, and that system we put in examples of, we wrote prompts that said, here's what it has to be in the first bullet, here's what it has to be in the second bullet. We would put in all of the features, the size of the bag, the count, if there are any allergens, et cetera, and it would write the description. And then what we would do is then the copywriters, the 2 that we had, all they had to do was read it. And if they liked it, they would say yes, and it could be moved on to Amazon. If they didn't like it, they marked it. It went back into our system, and they type in a little thing, I don't like it because of this, and then we could continue to train our model and have it get better. Now, I do want to point out on a side note that I did do this image by typing a prompt that said, make a cute robot that's writing something with Reese cups. And sure enough, it got the logo exactly right. Copyright infringement. One more, and maybe this will be a little closer, although I have a feeling, given the conversations that I've had up to this may be not up to date, because I know there are tools out there that are more along the lines. But one of the things we did was we went to the legal team, and we said, do you have any challenges where your people are just grinding through stuff that you'd rather they didn't have to do? And they said, yes, MNDAs, please. If you could help us with approving red lines to MNDAs, that would save us, our junior attorneys, so much more time. They could do so much more important things. So we set out to do that. We took another generative AI model. We put in information about what it could and what it could not change. And we had it look through all of the red lines, and it would change the ones it could, and it would specify why. There would be some information that we would give it to tell us, say, tell us this when you do it, why you're doing it. And then it would flag the ones it couldn't. And then only those would go to the junior attorneys. And then they would look at it, and if we saw a systematic thing that it wasn't doing right, we could then add that again and take a little more off of them. So that incremental model of moving things back and forth, getting it to the expert, having them comment, taking it back, incorporating it into the model is one of the ways you build these things up over time into something truly powerful. I may have to go a little quick through this, but I wanted to give you a flavor of what it takes to create an AI group in an enterprise if you're starting from scratch or you're trying to build up into something more useful, or something more along the lines using generative AI. The first thing is you have to understand yourself first. You have to know what you know and what you don't know. And if you don't know the Rumsfeld Knowledge Matrix, I urge you to go read about it. It is fantastic. It was done by Donald Rumsfeld, probably by accident in a way, who was a former defense secretary for Bush, I believe. He has known knowns, known unknowns, unknown knowns, and unknown unknowns. And I want to claim that you have exactly the same thing in your company related to generative AI. So let's quickly go through each one. Known knowns. These are things that you already know. You got a champion inside your group, inside your company, who's already interested in Gen AI, who's already doing some of these things on their own, maybe sneaking a little work time in to try and understand them a little better, thinking about how it might be able to affect positively your company. So you know those, and you may know those people. They may be talking to you. They're available. Unknown knowns. There may be another champion in there you don't know is doing this stuff. They're doing it at home. They're training themselves just because they're interested. So you need to go find those people. And how do you define them? How do you find them? You offer things that will draw them to the person who's a known known, and then you start to build that community. Known unknowns. These are the things you don't know. A lot of you, hopefully, there was something in this talk that you don't know, and now you don't know it. And so you can go out and seek that information and acquire what you need. And when you do that, once again, it becomes a known known. And lastly, the most fun, and the one that twists a lot of people's brains, is unknown unknowns. This is your blind spot. These are the things you don't know that you need to know, and they're unknown to you. See, I can't even explain it right. Research from other companies. I'm sorry, how much time do I have left? 1 minute. Okay. All right, I'm going to have to skip to the end. I'm sorry. I'm happy to talk about a lot more of this with everybody. That's my favorite one. I wish we could have got to that. But I want to close this off and give some time. Okay. Apologize for skipping ahead. Can anybody read this? I'll get you started. Oh, see, Billy. See, ergo 40 buses in a row. No, Billy, dem is trucks. See what is in them? Anybody? Cows and ducks. Sometimes the way things are presented to us fool us. They make us think they're more complicated. We don't know how to use them. We don't know how to relate to them. But it's all just the window dressing. The value's still there. The meaning is still there. You've got to get past the way things look, the way other people are talking about them. Don't judge the book by the cover. Don't judge Gen AI by the headlines. Thank you.